At Synergy, we really pride ourselves on being on the forefront of technology, not only with the tools and processes that we use like analytics and fault detection or Revit or 3D scanning, things like that, but we also are constantly exploring better pieces of equipment and better ways to serve our clients and to solve their problems moving forward. And that carries over into our designs and our selection and our specification of certain types of equipment, whether it be magnetic bearing chillers, tracking pair Venturi VAVs on operating rooms, things like that. We're always looking to strive for what is the best use of technology that we can use towards solving our clients' unique problems. And one of those pieces of technology that we're seeing more and more of and being asked by our clients to explore more and more is the use of fan array systems. Now, when we're talking about fan array systems, we're looking at air handling units or rooftop units. And typically in the past, when we're designing and selecting air handling units, we've always looked at single fan systems, and those have worked well for very many years. But as we're looking towards becoming better, more reliable, more efficient, the industry has moved towards using a fan array system. So what we're going to talk about real quickly is what is a fan array system, why use it, and then kind of the top 5 things that we normally look at when we're selecting or possibly looking to apply a fan array system for a client's specific needs. So why use a fan array system? There are many problems that can arise when an air handling unit fan fails, especially when that air handling unit serves critical spaces. Typically when we're working in a hospital, we're looking at a lot of critical spaces, whether it be isolation rooms, operating rooms, things like that, where we really need to always consistently, reliably maintain certain conditions within a space, not only for proper comfort, but also for patient and occupant safety. So when we have a single fan that fails and we have downtime on that air handling unit, it creates a tremendous amount of problems. One of the biggest concerns, like I just said, is downtime, which can impact patient safety, occupant safety, and comfort, as well as result in loss of revenue from the downtime of that unit. If that unit serves operating rooms and they can't perform surgeries, then that's a loss of revenue for the hospital. So it's a very big pain point having a single point of failure within your air handling systems. And they also can provide a very great strain on the facility team's maintenance efforts if they're constantly trying to replace a single unit or trying to keep something up and running while they're replacing something. It's just very taxing on that team. There's really a 0% chance of an immediate fix when a large single fan system fails within an air handling unit. There's just, with the lead times where they are now in terms of getting certain equipment, it just takes a long time for parts and pieces to arrive in order to properly fix some of these things. So having any time of extended downtime, it's not going to be an easy, quick fix. It's usually going to be a failure that could take days, weeks, or even months in order to get that system running again. So that impact on occupants, loss of revenue, and stress in the facility team can be very, very significant. So what is a fan array system? So what we're looking at is taking away the single fan and creating a system where we have multiple smaller fans handling that same amount of airflow. And usually those fans are direct drive, electrically commutated fan array system, or EC fan system. And what we look for when we're selecting and sizing these systems are 5 different things. We're looking at the ease of installation. Those fan array systems are a lot smaller and lighter components and are easier to manage and require less time and effort to install. So most of the components that we have are small enough where they can fit through open doors. So when we're doing maintenance and repairing and moving things in and out, there's a tremendous amount of labor and operational savings just because we don't have to have a tremendous amount of equipment or a large team in order to do the repairs. That leads me into the second point, and that's the ease of operational maintenance. With these smaller direct drive fans, there's no belt or shivs that need to be adjusted or replaced, and the fan array can be maintained and repaired with ease, often without ever having to shut down the unit or impacting any airflow to the downstream spaces. One of the third great benefits of a fan array system is the redundancy. As I talked about earlier, a single point of failure is just a tremendous tremendous problem when that unit is serving critical spaces. So having the redundancy that if a fan fails, the other smaller fans within that array can compensate and still provide the required airflow while that trouble motor, trouble fan is being repaired or replaced. So we're not losing any downtime, and we're not losing any revenue or causing any types of issues towards the patient and occupant safety within that space being served by that system. The fourth thing we look at is the greater efficiency of the system, right? So multiple smaller fans provide greater energy efficiency, and that in tune provides longer, more reliable operational efficiency as well too. I've talked about it, a lot, and that's reduced downtime. So when we have less downtime or no downtime, that really allows the spaces being served by that unit to operate interrupted without any type of worry or trouble that they're going to lose system performance. And on the back end of that really helps out the operational maintenance team, knowing that they're not going to have that headache, and knowing that if there is a problem that arises, they can still maintain system airflow and work on that unit without impacting anything downstream, where as far as the people in the space really know that there's not an interruption at all. So and then the last thing that we look at is sound performance, right? So smaller fans provide a lot lower radiated noise than belt-driven fans, and that lower octave is a lot easier to attenuate. So overall, even though we have more fans, you would think they would be louder. They operate at different sound levels, which actually makes them quieter than a large single fan system. So those are the types of things that we look at when we're specing a fan array system. We're going to go into a different video and talk a little bit further about how we select fans at each one of those bullet points that I just described and why they're important.